This video is a supplement to the Kinetic Arm assembly manual. The download link for the assembly manual is in the video description below. The scale of the Kinetic Arm in this video is a right hand, 70% lower component scale, 70% upper component scale, with a Type B forearm as per the example given in the assembly manual. Before you begin mixing the silicone, make sure all of your molds and equipment are ready, as the silicone has a short working time, so you will need to work quickly. We recommend you lay down some paper to keep your workspace clean. The silicone quantity we're using today is for a 70% scale kinetic arm requiring a total of 58 grams of silicone. We're working with a two-part skin-safe silicone, so we need to measure out 29 grams of part A and 29 grams of part B. These measurements vary depending on the scale of the kinetic arm you are making. Remember to tare your scale before each pour. Precision is key for proper silicone curing. Take your time pouring, aiming for the exact measurements. The closer you get, the better the silicone will set. We use a chopstick to stir the silicone, ensuring it's mixed thoroughly. You can use whatever you have available. Do your best to stir the silicone off the sides and bottom of the container and act quickly. Silicone sets fast, so you will need to work within the material's working time. Gradually add your colorant. Add a few drops at a time, stirring thoroughly. Repeat until you achieve your desired color. We choose to use CMYK printer ink, but you can also use oil-based paints. Don't overdo it. Too much colorant can adversely affect the curing process. When pouring the finger grips, fill just above the top of the mold without it overflowing. Using the same tool as used to stir, scrape the excess silicone from the top of the mold. We are aiming to achieve a flat surface so that the finger grips fit into the kinetic arm. Take your time, as moving too fast can pull out the silicone. Pour the remaining silicone into the deepest part of the palm mold. Pour in a slow, even stream to minimize air bubbles. Place part 2 of the palm mold gently into part 1, starting at the deepest part of the palm mold. Use a gentle rocking motion to achieve an even overflow right around the mold. This also encourages air bubbles to escape. Again, you want it to overflow evenly around all the edges. Place any weighted object on top and try to keep the mold centered. We use one of the bottles of silicone. Leave the silicone in the molds to fully cure as per the setting times for your silicone. Start by cleaning the glue residue off the base of any printed parts using a wet paper towel or cloth. Use flush shears to trim any burrs or stringing from the flexible TPU components. Remove the supports from the thumb hinge slot. Lay out each of the finger and hinge components in the correct order and orientation before assembly. Pay close attention to the part numbers on each part. Use the matching numbers to correctly identify and attach the components. As this is a right-sided kinetic arm, all hinge numbers will be in the bottom right corner. Note that if you are making a left-sided kinetic arm, the numbers on each of the components will be mirrored and in the bottom left corner. Insert the first side of the hinge by hand. Pliers can be used to stretch fit the other side into the hinge slot. Pay close attention to the video as it shows the correct assembly orientation and numbering of components. We'll now attach each finger to the palm, starting with the thumb. Match the number on the bottom hinge with the number in the correct location on the palm. Insert the curved side of the thumb hinge into the palm first. This side is slightly longer, which will make the other side, which is shorter, easier to insert. Use pliers to stretch fit the other side. Make sure the pliers do not make contact with the rigid PLA components, as this can damage the plastic. Insert the side of the hinge closest to the neighbouring fingers into the palm first, then use a set of pliers to fit the other side. Insert the remaining finger hinges from the side closest to the fingers already inserted to allow more space to use the pliers when stretch fitting the hinges. Repeat this process for the remaining fingers. Check that each finger comes to a complete close. In this section, we'll be attaching the palm, forearm, and upper arm. We'll begin by correctly orienting the gasket. You'll notice there is a curved and a flat side. The curved side sits against the palm, and the flat side meets the forearm. Align the two guidelines on the palm and forearm. Insert each of the 4 M3 stainless steel cap screws into the holes of the locking mechanism. Attach the extension bit to the socket screwdriver and insert a 2.5mm hex bit into the end. While holding the palm and the forearm together with the guidelines aligned, place the locking mechanism into the forearm cavity. By rotating the locking mechanism, you should feel the bolts align with the 4 holes in the palm. Force must be applied to the hand and forearm to hold them together while tightening. Resting the hand against your lap and applying a force downwards can help. The screws must be tightened in a particular order, starting at the front, moving to the back, then to the left and right. We recommend doing 5 full rotations on each screw before moving on to the next one in sequence. Make sure you do not tighten one screw completely while the others remain loose. We do this to ensure an even force distribution and that the palm and forearm are correctly aligned. Achieving the optimal tightness is challenging and can take time. It is a fine balance between too loose and too tight, but it is very important you get this right. After a couple of cycles of tightening the screws, check the connection between the palm and forearm. If the forearm can be lifted away from the palm, tighten each screw by 1 full turn. Again, check the connection by holding the palm and forearm and try to rock them back and forth. If you can feel any movement between the parts or see any gaps appear in any direction, the connection is still too loose. The screws in that direction need to be tightened further. It is very easy to over-tighten the screws. The forearm should be able to easily rotate against the palm. If considerable force is required to do so, loosen each screw by 1 full turn. Continue to iterate through this process, tightening or loosening and checking the connection each time. It can be a slow process to get right, but it is very important that you do. The optimal tightness is reached when the palm and forearm cannot be pulled apart and no gaps appear when the wrist is bent in any direction, but it is still easy to rotate the forearm against the palm. Here you can see that the gasket is pulled tight and not rotating with the forearm. It should not be loose or able to rotate freely. We'll now attach the forearm to the upper arm. Insert the outer side of one of the elbow hinges into the forearm. Then twist the hinge and secure the other side. Make sure that the hinges are oriented the correct way, with the wedges facing in the direction shown in the video. Repeat for the other elbow hinge. It is more difficult to connect the hinges to the upper arm. Do not be disheartened if it takes multiple attempts. Using pliers can help to first insert the outer side of the hinge. Once inserted, you should be able to push the inner side of the hinge into the designated hinge slot in the upper arm. Repeat for the other side of the arm. The forearm and upper arm should be slightly bent at rest. This is intentionally designed to stop the elbow from hyperextending when worn. In this section, we'll be threading each of the tendons through the kinetic arm. Use the table to find the required length of leader line for the upper component scale of your kinetic arm. Cut one length and fold it in half. Take care when cutting. Use needle nose pliers to crimp the end into a small loop. We'll use this to assist in feeding tendons through blocked or tight channels. Find the matching tendon length for your upper component scale. We are making a 70% arm, so we'll need to cut 5 lengths of PE braided line at 1600 millimeters each. We'll begin by threading one end of the tendon through the thumb until it begins to poke out of the hand. Then thread the other end of the tendon through the second thumb hole. When pulling through, match the ends of the tendon pairs to ensure that they are the same length. Feed both of these ends through the palm into the forearm. Repeat the same process, threading one end of the second tendon through the index finger, followed by the other. Sometimes the tendon channels can get clogged, or the fishing line may fold and become difficult to thread by hand. Using pliers or the leader line can help. Pass both ends through the hand into the forearm. Watch out for the tendons catching on the fingers as you pull them through. Take the folded leader line and thread it through the upper arm and forearm channels towards the hand. Make sure you are threading it through the channels on the same side as the thumb. You may need to use a set of long needle nose pliers to pull the leader line through the hole. Take all 4 tendon ends and pass them through the loop in the leader line. Only feed about 100 millimeters or 10 centimeters of the tendons through the loop, as this helps when pulling the tendons back up through the arm channels. Pull on the end of the leader line to thread the tendons through the arm. We'll now thread the last 3 tendons through the middle, ring and little fingers, following the same process used for the first 2 fingers. Again, using the pliers or the leader line can help. Feed the leader line through the arm channels on the little finger side of the arm. Watch out here. If the wrist and forearm have rotated independently of each other, the locking mechanism can block the opening of the tendon channel. Make sure that the guidelines are lined up with each other. This should allow you to access the channel opening. Using long needle nose pliers, pull the leader line through. Again, only feed about 100 millimeters of tendon through the loop in the leader line. Pull on the leader line to thread the tendons through the other side of the arm. We now need to separate each tendon into its corresponding channel in the tendon divider. These align with the order of each finger. Begin by choosing a tendon end and pull it. When you do so, you should see one of the fingers flex. Here you can see the thumb flexing as we pull on the tendon. Feed this through the thumb channel, which is the leftmost one. Just note here that if you are making a left-sided kinetic arm, the thumb channel will be on the opposite side. Pull on another tendon and look for finger movement. In this case, the index finger flexes, so we'll thread this through the index finger channel, the second one from the left. Repeat this process to identify and thread all tendon pairs into their corresponding channels. Check that all of the tendons have been threaded properly. We'll now repeat the same process to separate each of the middle, ring, and little finger tendons into their corresponding channels. Once all of the tendons have been threaded, check by pulling on each tendon pair one by one, and make sure only the corresponding finger flexes. In this section, we'll be tying off and tensioning each of the tendons to achieve the ideal closing pattern for the fingers. Refer to the table to find the length and gauge of screws required for each upper component scale. You will need 8 screws in total. We'll be screwing the tensioners into the middle holes to allow for future adjustment if required. It can help to begin screwing by hand to keep the screw in place as you align the tensioner over the hole. We'll now begin tying off the tendons. Starting with the thumb tendon, lift the tensioner and feed one end of the tendon pair up through the bottom and out the other side. Tie a temporary reef knot by folding the right side over the left and pulling before folding the left side over the right. Pull tight. Aim for these knots to sit in between the tensioner and the tendon divider. We'll do the same for the index tendons. Sometimes the tensioner holes may be clogged or tight. If so, use the folded leader line to help thread the tendon through. Again, fold right over left, then the left over right to tie a temporary reef knot. This knot will be able to slip up and down the tendon. Repeat this knot for each of the remaining tendons. Some of the knots may have come loose and need retightening. Remove any slack from the line, but do not over-tighten them to the point where the fingers begin to flex. Tuning the fingers to find the optimal hand position is really important for the function of the kinetic arm. Without bending the elbow, check the hand. If any of the fingers are excessively flexed, pull on the end of the finger to move it to the correct position. This will allow the temporary reef knot to slip to the correct position. If any of the fingers are lagging, check the corresponding tensioner. The knot will likely be loose and require further tightening. This is a bit of an iterative process, back and forth, but it is extremely important. Check that all fingers are in the correct position by very gently flexing the elbow. You should see all the fingers begin to engage at the same time. Do not flex the elbow all the way, as this will loosen all of the knots and the tuning process will have to be started over again. Once you are happy with the hand position, we can begin to tie the permanent knots. Start by following the same steps as the temporary knot, folding the right side over the left. Then fold the left side over the right, but add in an additional 4 twists. Holding the middle of each side of the knot, align the center of the twisted section over the top of the knot. Pull each end gently and slowly. The knot should tie down directly onto the existing knot. Then pull the knot tight to secure it permanently. Again, begin by folding the right side over the left and pulling tight. Then fold the left side over the right and add another 4 twists. Remove any kinks in the tendon by grabbing the middle of each side and aligning the twisted section over the top of the existing knot. Pull tight. Repeat this process for the remaining 3 knots. Check the hand position. The elbow can be fully bent now. All 5 fingers should begin to flex at the same time. There should be a nice even arc around the fingers as they close. The thumb should tuck in below the index and middle fingers. All fingers should come to a complete close. In this case, the ring finger is lagging behind the others as they begin to close. Find the corresponding tensioner and remove the screw. Pushing down on the elbow joint can help to remove the tension from the tendons. Move this tensioner back one hole and re-screw. Check that all fingers are closing at the same time. Another case may be that the ring finger is leading the others. This time, unscrew the corresponding tensioner and move it forward one hole and re-screw. Sometimes one of the fingers may be lagging by a small amount. Moving the tensioner hole position forwards will over-adjust the finger and affect the hand closing pattern even more. To make more precise adjustments, the tensioner can be unscrewed and twisted. This shortens the length of the tendon in the arm and tightens the lagging finger. You may need to twist and re-screw the tensioners multiple times to make precise adjustments to the fingers, checking the hand closing pattern each time. Cut the excess length of the tendons from the knot. Take care to cut away from the body. Using a medium to thick gel superglue, add a small amount to the knots. Do not let any of the glue run onto the forearm or along the tendons, as this can weaken them and lead to tendon failure. Leave the knots to set as per the drying times on the glue. Do not flex the arm while the glue sets. We use an accelerator spray to speed up the glue setting process. Spray a small amount onto each knot. Once they begin to turn white, they have set. Three 2x8mm screws are used to secure the upper arm cover to the upper arm for a 70% upper arm scale. Be careful not to over-tighten the screws, as this can damage the parts. Like puzzle pieces, the four parts of the neoprene liner fit together to form a complete template. Use sticky tape to secure the four parts together. Use a permanent marker to trace around the template on a piece of neoprene. Be careful to not move the template whilst tracing. Make sure you don't forget to include the slits in the middle of the template. Use material scissors to cut around the trace marked on the neoprene. Always be careful when using sharp tools like scissors or a hobby knife. Use a hobby knife to make the slits in the middle of the neoprene. An easy way to cleanly cut the slits out is to use the hobby knife to do 2 long parallel lines, and then use the material scissors to cut between the 2 parallel lines cut with the hobby knife. Lay the neoprene liner inside the kinetic arm and secure it down with the Velcro straps. Feed the Velcro strap into the bottom slit of the kinetic arm first, ensuring that the rough side is facing up. Then through the bottom slit of the neoprene liner. Fold over the Velcro strap and feed back through the top slit of the neoprene and kinetic arm. Finally, pass the end of the Velcro strap through the buckle attached to the other end. Repeat this same process for the other 4 Velcro straps. This next stage is a difficult process and may take a few attempts to get right. Please be patient. To make the kinetic arm more stable, twist the hand so that it is on its side. Ensure that the locking pin has the side with the hole facing up. This is the correct orientation. If the locking pin needs to be removed in the future, a screw can be inserted into the hole in the locking pin to pull it out again. Begin by slightly pushing the locking pin in. You need to push it just far enough to get it through the neoprene liner. Push the forearm insert into the forearm, aligning the whole of the insert with the locking pin. Push the locking pin up through the insert until you see it appear at the top. Fold the top of the neoprene liner over the insert and tuck it into the sides. Push the locking pin through the cutout on the top side of the neoprene liner. Place the tongue so that the center aligns with the free 3D hands logo at the top of the forearm. Use the tongue to move the locking pin back or forth into the right position so that it can be pushed all the way into the recessed slot in the forearm. Work the Velcro strap through the neoprene and corresponding kinetic arm slit. It can be a little tight, so push against the forearm insert to compress it, giving yourself more space to work with. Pull the Velcro strap all the way through, fold over and secure on top. Repeat this same process for the remaining Velcro straps. Remove the silicone parts from the molds. clean any excess flash using small side cutters. Place the palm spacer inside the silicone palm. Push the silicone palm into the hand, starting at the front to lock in the 3 locators, and then work it in gradually towards the back. Put the finger grips in, this time starting at the back. Squeeze the sides of the grips to make them fit, as they are trapezoidal in shape and designed to lock in once inserted. Once the back is in, the front should push in slightly easier. Repeat this process for the remaining fingers. Part numbers are molded into the finger grips, so make sure that you match to the corresponding part number on the fingers. You have now completed assembling the kinetic arm. Congratulations! Thanks for watching, and don't forget to hit the like and subscribe button for future design updates. We would love to add your kinetic arm makes to our collaborators wall in the free 3D Hands Design Center. Please email your photos or any questions you may have to info@free3dhands.org. We would love to see how you are changing the world one arm at a time.